Hi guys, in this video we are going to see a basic operating system concept which is called as deadlock. So let's see what it means. Let's start with its definition. So basically deadlock is a situation where a set of process is blocked because each process is holding a resource and waiting for another resource acquired by some other process. So diagrammatically what it means is that let's assume that there are two processes, process 1 and process 2, and you can see that process 1 is waiting for resource 2 and process 2 is waiting for resource 1. So, and also the process 1 is holding resource 1 and process 2 is holding resource 2. So basically it means that for process 1 it requires resource 2 but it holds resource 1, and process 2 it requires resource 1 but it holds resource 2. The resource will be allocated to each process if any one of them will release the resource so that it can be utilized by one of the process, and that process will release the another resource which can be utilized by the second process. But in this scenario neither both of them are ready to release the resource and waiting for the other resources. So this situation can lead to a deadlock, means it cannot be processed further. They keep in a loop waiting for each other to release the process, and in this way there can be issue, the system can be crashed, the program can be crashed, anything can be happen. So this is a basic example of deadlock. To understand it in the real life example, any funny example, suppose you want to go to any road trip and you need to take a permission from mom and dad. Okay, so what mom tell that? First take permission with dad, and what dad tells us that first take permission from mom. So in both the scenarios, one is dependent on other and other is dependent on the first one, and both cannot proceed because any one of them need to take the decision, or else it will be in a circular manner. One will be dependent on other will be dependent on first, and the program cannot be executed further. So this is the common basic example for the deadlock in operating system, and there are some predefined conditions for deadlock to be happen. So let's see what are those conditions. Okay, so first one is the mutual exclusion, which means that two or more resources are non-shareable, means only one process can use at a time. There is one resource, and suppose there are two processes. So this mutual exclusion means that this resource can be utilized by any one process, either process 1 or process 2. It cannot be used simultaneously by both the processes. Okay, and if this condition holds true, then both cannot use the single resources, and a deadlock can happen if this resource is required by any other process. Okay, next one is hold and wait. It means that the process is holding at least one resource and waiting for other resource. Suppose this is a process P1 and it is holding resource R, and the same resource is required by process 2. Okay, but this process 1 is not ready to release that resource, and due to that process 2 needs to wait. Okay, so this waiting condition can lead to any delay in executing the program or maybe cause any system issues. Okay, so this way the hold and wait condition works. Next one is no preemption. A resource cannot be taken from a process unless the process release the resource. Suppose this is a process P1, it is utilizing resource R, and P2 wants that resource. So it is not possible for the process P2 that directly go and take this resource from the P1, because this thread can be executing some important work with the help of this resource, and it is not possible for the P2 to directly go and take this resource. Okay, so in this way norm preemption works. And circular wait. So for circular wait, it is like a set of processes waiting for each other in a circular form. Okay, so let's see, this is a process P1, process P2, P3, P4, and P5. And P5. Suppose these processes are holding R1, this is holding R2, this is holding R3, R4, and R5. Okay, so P1 requires R5. Let's say P1 requires R5 and it's holding R1. P2 requires R1 but it's holding R2. P3 requires R2 but holding R3. P3 requires R4 but it holding R3, and P4 require R5 but it is holding R4. So none of these processes are ready to release the resource because they are waiting for the corresponding resource, next resource. And in this way, this led to an circular wait. So each one of the processes is waiting for the corresponding next resource, and these next processes are waiting for their corresponding next to next resource. So in this way, they led to an circular wait, and neither of them are ready to release the resource because this no preemption holds true, and that's why it leads to an deadlock. Okay, so this was all about these necessary conditions for deadlock. This was all about this video. In this video, we had seen how deadlock occur in the operating system. It's basic day-to-day life example, and then what are the necessary conditions for deadlock in OS. So in next video, we will see some another concept related to operating system or CN anything. So subscribe to my channel to get daily updates or weekly updates regarding any computer science fundamentals. So see you in next video. Bye bye.